Nothing too dramatically different here, okay? Nothing too dramatically different, but
So it's basically the opposite.
it's exactly right. Depreciation, year 10, is the opposite of compound interest. Compound interest is when I put something into an account and it grows over time. We call that appreciation. So when I have something and the value increases. Now there are certain objects potentially that do that, like maybe like vintage cars or like Lego sets and like sets like that. Yeah, some of those things appreciate over time. Most things that you buy, like your laptops and your smartphones and things like that, when you buy them, right, over time they will have less value when you try and sell it later. That's called depreciation. Yeah, most cars.
You drive out of the dealership with that car, you just lost a little.
You've lost like 10%. I've heard that expression as well. Some cars it may appreciate in value, depending on maybe if it's like a Ferrari or something. I don't know. But the formula for this, the formula is very similar, right? That looks very familiar. What's the only difference? This is a minus, right? Minus. Everything else is the same. A is the final amount, P is the principal, N is the number of periods, and R is the rate of depreciation. Now, with the principal, I guess it's not necessarily a lump sum of money, right? It might be the value of the product. And for these ones, unless they specify, you can assume that it's compounded annually, so you don't have to do any adjustments there. Let's look at these pretty straightforward examples. We've got Naomi, who bought a computer 3 years ago for about $5,680. Pretty expensive computer, maybe it's like a Mac or something, I don't know. Depreciating at 8% per annum, right? How can I go about this? Well, I'm looking for the final amount after all this time. So I know that it's initially worth 5680, and I multiply it by the rate. Lucas, what's the rate in this case? Yeah, so multiply by 1 plus the rate, 1 minus 0.08, and all to the power 3. So 4422.994. Okay, so if I wanted to sell this thing 3 years later, I've lost quite a bit. I've lost almost $1,000 off that.
Round it up to
9.5. Okay.
Is that how much computers are these days?
Maybe not most computers. Most computers are not that much, not that expensive, right? Okay, how can I use this for other kinds of problems though, right? Well, one thing that we look at very commonly is how long does it take for something to be half its value, right? The reason why we look at something like this is for tax purposes. Sometimes if you own a company, you can write off things as a tax deduction once it gets to a certain value in terms of a percentage, right? So if I look at something like this, I've got a farmer, they buy an excavator for $500,000, apparently that's how much they cost, and it depreciates at a rate of 18% per annum. Find how long it takes to reduce to half its value. It's a slightly different question, right? I'm not looking for the final amount anymore. I'm looking for how long it takes to get to half its value, right? Have a think about this really carefully. Matt, can you tell me, what do I want the final amount to be? Or, yeah, what do I want it to reduce to? 250,000. I want A to equal $250,000. Rips, can you tell me, what's the unknown in this equation then?
The amount, the percentage.
Find how long. What's the duration in my equation? Which represents how long? Yeah, the number of periods, n, right? So I've got this equation right now. I know the starting value, that's 500,000 times 1 minus the rate. 1 minus 0.18 to the power n. This is the problem I have here, right? I'm trying to... So n is the number of periods that I have. Yes, you can. You could let A be 250,000, but the problem is, right? The problem is I'm trying to look for n. Okay? So if you want to, I can let this be 250,000, and I can try and solve for n, right? At this point in time, you guys don't have enough tools to solve for something like this. So the way that they suggest is use guess and check, right? You say, okay, let's try for different values of n and see how long it takes until I reach 250,000. So I'll pick on a couple of people. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you guys all plug in different values of n for me into this? Right. So I would try multiple values, like n equals to 1 to see what a equals to. maybe n equals to 2, n equals to 5, n equals to 9.
12.
I think I gave everyone a number. Has anyone gotten to 250,000?
What was that?
Between 3 and 4.
Between 3 and 4? So who was 3?
I was 3.
You were 3? What did you get?
I haven't done it yet.
Oh, can you plug it in?
Yeah.
No, it's not very
I'm 4, I got 226,000 and 60.
226,060.
Wait, Matt, what's the answer, Matt?
And Jade was 3. What did you get?
2, 7, 5, 6, 8, 4, 0.
We know that it happens between 3 and 4 years here, okay? So to answer this, how long will it take to reduce to half? Well, at this point, n equals to 3, it's not actually half, right? So we could just say between 3 and 4 years. At some point there. Like I said, we don't really have the proper tools in order to find the exact value for n, okay? But we will be learning that later on in the year. We have to use something called logarithms in order to do that.
Oh, is that the one with log on the calculator?
Yeah, that's right. And we'll be learning that next term, okay?